Lesson 2-9B, uniform motion. Uniform motion problems, or rate problems, are problems in which an object moves at a certain speed or rate. The formula that we're going to use is D equals RT, meaning distance equals rate times time. If an object moves without changing its speed, it is said to be in uniform motion. So for example 1, it took Travis and Tony 40 minutes to skate 5 miles. The return trip took them 30 minutes. What was their average speed for the trip? So something that we need to know and understand with these kinds of problems is that the boys did not travel the same amount of time on each portion of their trip. So we're going to figure out the weighted average of their speeds. So we're going to first practice by just finding the rate of each of the boys' trips. And to do that, we need to figure out what our formula would be for rate. So since we know distance equals rate times time, rate equals, to get rate by itself, we would be dividing both sides by t. So rate equals distance over time. Okay, so if we were to look at the going, they're going to travel 5 miles. So I'm going to plug that in for D. But their time is in 40 minutes. Something that we need to practice and make sure that we know is that when we're working with rate of trips, we're talking about miles per hour. Okay, so since it's given to us in 40 minutes, we need to convert that into hours. In the example they give you as a decimal, I like to use fractions, so I can think of 40 minutes out of 60 minutes as in 2/3. So I'm going to do 5 divided by 2/3, which is that complex fraction. So if I do keep, switch, flip, I end up getting 15/2, which equals 7.5 miles per hour is the rate of them going. To figure out the rate of the return, same idea. They're going to return back, so the distance is going to be 5, but this time the time is 30 minutes. Okay. Once again, I'm going to change that. Instead of using a decimal, I'm going to use a fraction, keep, switch, flip, and I end up getting 10 miles per hour. Now, all this is doing for us is figuring out the rates of them going and them returning. Okay, so if we're trying to figure out the average for their round trip, okay, we're going to use this formula here. So M, which remember from lesson 2A stands for weighted averages, is the rate of going times the time of going, plus the rate of return times the time of return, all over time of going plus time of return. To me, that is way more complex than it needs to be. If we think about the rate of going and the time of going, rate times time equals distance. So really, this is distance going plus the distance return. And it's still over the sum of the time. So for this one, what we would do is we would take, so the distance going is 5. The distance return is 5 because it's a round trip, they're going back. The time of going, remember, is 2/3, and the time of the return is 1/2. So now we're dealing with fractions on the bottom. So I'm going to have 10 over, remember when I'm adding fractions, I need to have like denominators, which in this case would be 6. If I add those together, I get 7/6. And then complex fraction, keep, switch, flip, I get 60/7, which equals 8 and 4/7 miles per hour. Okay, so that would be the average speed for their trip of the going and then the return. Okay. Example 2, same idea. So Nita took a non-stop flight to visit her grandmother. The 750 trip took 3 hours and 45 minutes. Because of bad weather, the return trip took 4 hours and 45 minutes. What's her average speed? Once again, if you wanted to find the rate of the going and the return, you can. Otherwise, remember, we can do distance going, and since they're going from one place to the other and then back, the distance return would be the same. The time that it took her to get there was 3 hours, and then 45 minutes, remember, it needs to be in terms of an hour, which is 3/4 of an hour. So I'm gonna go ahead and do 3.75 plus, and then the return, same idea, 4 hours and 45 minutes, again, 3/4, so 4.75. If I add my numerator together, I get 1,500, and then my denominator, I get 8.5. I'm gonna go ahead and divide those out, and I get 176 miles per hour. Okay. Example 3 is very similar. Austin jogged 2.5 miles in 16 minutes and then walked 1 mile in 10 minutes. What was his average speed? For this one, because they're already both in minutes, it's just as easy to leave it in minutes. If you want to convert it into hours, by all means, feel free to. So for this one, we're going to go ahead and do 2.5 miles for the jog and then 1 mile. Okay. And then it's 16 minutes plus 10 minutes. So I have 3.5 over 26. And then if I divide those out, I get about 1/1300 miles per minute. Another type of problem that we're gonna do is also gonna involve distance equals rate times time, but this time we're gonna involve 2 different vehicles. And what you wanna know for these is that there's 2 different equations. If they're going the same direction, so starting in the exact same spot, heading the exact same way, you're gonna set their distances equal to each other. And the reason I'm doing D1 and D2 is because there's 2 different vehicles. If they're going in opposite directions or going towards each other, okay, this one you're gonna do distance of the first object plus the distance of the second, and we're gonna set it equal to the total distance that they're traveling. Okay, so these are the 2 equations that you're gonna wanna make sure you know and learn. So freight trains. 2 trains are 550 miles apart heading towards each other on parallel tracks. Train A is traveling east at 35 miles per hour. Train B travels west at 45 miles per hour. When will the trains pass each other? So whenever you're given a problem where it gives you the distance that they're gonna be traveling, and notice how they're coming towards each other, so they're going opposite directions of each other, we're gonna use this first equation. D1 plus D2 equals total distance. Okay, so for these, you wanna just make sure that you distinguish which train is D1 and which one's D2. It really does not matter. So I'm gonna just do train 1 is D1, train 2 is D2. So if I look at train A, they're traveling at 35 miles per hour. When I see miles per hour, that's already signifying my R of my equation, because remember, we're still using D equals RT, but we're doing that for each object. So the rate is 35 miles per hour, but we're trying to figure out when will they pass each other, so we're trying to figure out that time. Okay, that's what we're solving for. So in this case, T in our variable is the number of hours until they pass each other. Train B though, D2, is going 45 miles per hour, but once again, we don't know their time. So if we're gonna use D1 and D2, if I'm gonna figure out D1, I just need to do rate times time. So it'd be 35T. Train B, 45T. So now my equation is gonna be 35T plus 45T equals 550. From here, I'm just gonna go ahead and solve for T. So if I add the numbers on the left, I get 80T equals 550. I'm gonna divide both sides by 80, and I end up getting that T equals 6.875 hours. Okay. We'll go ahead and try another one. That's actually, this example 5 and example 8 is gonna go back to what we were doing for the first part of the lesson. So we'll work on 6 and 7 first, and then we'll go back to 5 and 8. So for number 6, a cyclist begins traveling 18 miles per hour at the same time and at the same starting point. An inline skater follows the cyclist's paths and begins traveling 6 miles per hour. At how much time will it take them to be 24 miles apart? So what's different about this one is they're starting the same location, but now they're going opposite directions of each other. Whereas the one we were doing before, the 2 trains were coming towards each other, so we were adding their distances together. This time, we're going to subtract their distances together since they're going away or apart from each other. So same thing, I'm going to go ahead and make a table. Feel free to use it or don't use it. It's really up to you what you prefer. And I'm going to say D1, D2, and I know I have rate, time, distance, and I have a cyclist, and I have an incline skater. So for the cyclist, his rate was 18 miles per hour, and we're still trying to figure out that time. So I multiply it across, that'll be 18t. And then for the inline skater, 6 miles, and we don't know the time, so 6t. So now remember, they're 25 miles apart from each other. Okay, so this time we're going to take D1 minus D2 and now solve. So 12t equals 24, divide by 12, t equals 2. So what this tells me is that in 2 hours, they will be 24 miles apart from each other. Okay, so very similar to what we did in example 4. Example 7, though, on the other hand, okay, is going to be a little different. So it says, at 3 p.m., Joe leaves home traveling at 40 miles per hour. 15 minutes later, Jim realizes his computer is in Joe's car and tries to catch up with him. Jim immediately leaves traveling at 57 miles per hour. At approximately what time will Jim catch up with Joe? So with this problem, what's happening here is that they are actually going the same direction. They're starting at the house and they're trying to catch up with each other. So for this one, this is where we're going to use that equation, D1 equals D2. So let's go ahead and figure out our D1 and our D2. So I'm going to have D1 be Joe, D2 be Jim. So rate times distance. So at 3 o'clock, Joe leaves his home traveling at 40 miles per hour. We don't know the T. But then 15 minutes later, Jim realizes his computer's in Joe's car, and Jim is immediately leaving traveling at 57 miles per hour. So what's different here now is that the time for Jim, he's leaving 15 minutes later. Okay, so we would have to take the 15 minutes and convert it in terms of hours, which would be 0.25. But since Joe's time is T, and Jim is leaving 15 minutes later than Joe, later meaning subtracting from, the time for Jim would now be T minus 0.25. Okay, we'll still multiply across 40t and then 57 parentheses t minus 0.25. So then D1 40t equals 57 times t minus 0.25. I have 40t equals 57t minus 14.25. I'm going to go ahead and subtract 57t since I have variables on both sides. I'm left with negative 17t equals negative 14.25. Divide by negative 17. I get that t equals 0.834. And remember, all of our time has been in terms of hours. But if we're trying to figure out approximately what time will Jim catch up with Joe, we would now need to convert these hours into minutes. So we need to take 0.834 times 60, When we multiply those out, we get about 50.04 minutes this time. And so we're gonna go ahead and just round it to 50 because it is approximately. So if Joe's leaving at 3 o'clock, we're trying to figure out what time will Jim catch up with Joe. So we're going to have to do 3 o'clock plus 50 minutes, which lets us know that at 3:50 p.m., Jim will finally catch up with Joe. Okay. Example 5, we're doing average speed. Okay. We have 16 miles in 2 hours plus 24 miles with 2 hours. I have 40 over 4, which equals 10 miles per hour. Okay, and then person biking uphill travels 15 miles, but in 45 minutes, so remember as a decimal. And then going down 15 minutes, but this time it's 30 minutes, so 0.5. So then I have 30 over 1.25, which gives you 24 miles per hour.